Welcome to our lesson on work problems. Let's first start off with the formula for solving work problems, and that is work rate times time equals work done, and you can abbreviate it as follows. Work rate is R, time is T, and work done is W. Now let's first define what work rate means. For a definition of work rate, we have fractional part of a job done in a given unit of time. For example, if someone can paint a room in 5 hours, then his or her work rate is the part of the job he or she can do in 1 hour. So imagine that this box represents the complete job. Now in 5 hours, 3, 4, 5, this person can get the work done. But in 1 hour, this person can only complete 1/5 of the work. So this person's work rate is 1/5 per hour. And it's important to understand this in order to solve these work problems. And before we move on, I forgot to announce this in the beginning of the video. You don't need to write anything in the video that's in blue, but if it is in black, please write it down in your notes. And so to finish a job, the sum of the fractional parts of the work done must equal 1. So for this person to finish this job, he or she must work for 5 hours to get the complete job done. So again, 1 represents the complete job being done. For our first practice problem, we have Rithvik can build a bookcase in 4 hours. Jacqueline takes 2 hours to build the same bookcase. How long will it take them to build a bookcase if they work together? The common misconception is that people can solve this problem by just averaging their hours. So 4 plus 2 is 6. 6 divided by 2 is 3. So it should take them 3 hours to build the bookcase together. But that is not what you want to do. You're not averaging their hours because they're each working at their own pace. So in setting up our chart, we have Rithvik, Jacqueline, rate times time equals their work done. So Rithvik's rate is, if he can complete a job in 4 hours, then in 1 hour, he can complete 1/4 of the job. Jacqueline will complete half of the job in 1 hour. So in terms of time, that's our unknown. And for our work done, you just multiply across. Whoops. And in order to complete the work, the sum of the fractional parts of work done must equal 1. So Rithvik's work effort, or work rate, plus Jacqueline's work rate together must equal 1 to complete the whole job. So to add these, you need to find a common denominator, or you can get rid of the denominators by doing an LCD. So in this case, I'll do that. So multiply both sides by 4. Multiply this side by 4 as well. So that's going to leave me with x plus 2x equals 4. 3x equals 4. Therefore, x equals 4/3, or 1 1/3. So in order to get the job done, they will take 4/3 hours, or you can write it as 1 1/3 hours together. Now we are going to move on to the second practice problem. So here we have JP takes 3 minutes to color a poster. Sneha takes 4.5 minutes to do the same job. If they work together for 1 minute and then Sneha leaves, how long will it take JP to finish? So please fix that in your notes. It should not say installer. That's from a different problem. So let's first start by setting up our chart. If you feel like you can finish the chart or complete the chart on your own first, go ahead and pause the video. If not, then just keep the video rolling and we'll fill it in together. Okay, so for our work rate, we have JP takes 3 minutes to color poster. Therefore, for his work rate, he can complete 1/3 of the poster in 1 minute. Okay? And for Sneha, it takes 4.5 minutes to do the same job. So for her work rate, what I'm going to do is convert 4.5 minutes to an improper fraction. That'll be 9/2. And if I want to figure out her work rate, I just divide 1 by 9/2. And that's just the same as multiplying by the reciprocal, so that will just equal 2/9. So again, to make sure that this is clear, JP, for example, to complete a job, or to paint this poster, it takes him 3 minutes. But if you split up those minutes into 1 minute each, in 1 minute, he can only complete a third of the job. And when you do the same thing for Sneha, she can complete the job in 4.5 minutes. So 1, 2, 3, 4, and then half over. In 1 minute, how much of the job can she complete? So you would divide 1 by her time, which is 4.5, and that gives you her work rate. Now, as for the time, this is the confusing part. Together, they work for 1 minute. So Sneha and JP have that 1 minute together. But Sneha leaves, and so JP has a certain amount of time to still work on the poster. So you're going to add N to JP's time because that's what you're trying to figure out. You don't know how much extra time it's going to take him to finish the poster. So when you write your work done, 1/3 times 1 plus N, you'll have N plus 1 over 3. And on the bottom, you'll just have 2 ninths. So when you solve for this, you're going to take the sum of their fractional parts and make it equal to 1. So JP's work plus Sneha's work to get the job done must equal 1. And so now to solve for N, you just want to either find a common denominator and solve it traditionally through fractions, or get rid of those denominators by finding the LCD. And on the left side, I get 3n plus 3 plus 2 is equal to 9 on the right side. And when I solve for n, eventually you'll get n is equal to 4/3 or 1 1/3. So JP will take 1 1/3 hours to finish the job on his own. All right, in our final problem, we have the following. Aaron, the mail handler, needs 3 hours to sort an average day's mail, but with an assistant, it takes 2 hours. How long would it take the assistant to sort the mail working alone? So when you set up your chart, you have Aaron's and you have the assistant. Oops. And again, for these work rate problems, the heading is always the same. So you have the rate times the time equals work done. So when you set this up, well, actually, let me have you try it first. Go ahead and complete the table on your own. And when you feel like you're done, go ahead and compare with what I have. If you want to keep the video rolling to make sure that you understand this, then just keep the video rolling. So Aaron's work rate is 1/3 because in order to complete the job, he needs 3 hours. But in 1 hour, he can only complete a third of the job, so that's how he got 1/3. Now for the time I'm going to write 2 because the work is done in 2 hours. So for the work done, it's going to be 1/3 times 2, which is 2/3. Now as for the assistant, we don't know the assistant's rate. So I'm going to write 1 over x. And again, together they're working for 2 hours. So when I find the work done for the assistant, that's 2 over x. When I set up my equation, I'm going to take Aaron's work, his fractional part, plus the assistant's work, and together they can get the work done. So it equals 1. So to solve for this, again, you can either use common denominators or try to get rid of the denominators by multiplying both sides with the LCD. So go ahead and solve for this equation. Pause the video at this point and find x. At the end, you should be able to get that x is equal to 6. So how long would it take the assistant to sort the mail working alone? It would take the assistant 6 hours. For your notes tomorrow, I want to make sure that you have the charts filled in and all the work shown in solving the equations, and we'll practice more of these in class to give you more exposure to different types of work problems. Now, as for the quote, if you do what you've always done, you'll get what you've always gotten. So I want you to identify the author in the form, and if you want to know what he looks like, this is Anthony Robbins. So he's that motivational speaker that you sometimes see on different TV shows. But if you do what you've always done, you'll get what you've always gotten. Go ahead and complete your notes. Make sure you bring any questions with you to class tomorrow, and see you then.